Hello, good morning, good afternoon, everyone. Welcome to today's presentation. My name is Mikhail. I am the Director of Curriculum Architecture at Web-Based Solutions Training and Consulting Company in Toronto. And I would like to welcome all of you to today's webinar, Data Engineering with Python and PySpark. In terms of logistics, I would like to make my presentation as useful as possible to you, so I would welcome your questions. Unfortunately, I wouldn't be able to allow you to speak. It will probably be not the best way to communicate a message. Send me a chat, or better still, put your question in the questions pane. So I can read it. If you have a personal question and you don't want me to mention your name, which I am not planning to do, just send me a private chat. Okay, so that's it. Let's get started. Today's presentation is going to be pretty short. It's a big topic altogether, and definitely we are not going to cover it in any depth, but we would probably touch some of the more important points, and I will try to maybe orient you towards achieving your goals, how you can see the forest for the trees and how things play together. So hopefully you'll find it useful on both technical level and maybe some sort of organizational level as well. So we will talk about data engineering discipline as a whole, because there is some confusion as to what it actually is. Probably the best way to understand what it is by looking at core skills and competencies of a data engineer. We will also, by way of example, look at how to deal with missing data in Python and PySpark. We will also mention quickly columnar data storage formats, which can help you in a big way with minimum involvement on your part in terms of the footprint of your data, the storage requirements, and speeding up your queries. So data engineering, it's essentially it's a software engineering practice where professionals in this field would be working on systems dealing with data. And data is king, as you know, and there are so many, I guess, initiatives built around establishing and promoting best practices for data acquisition, transfer, which fall under the category of ETL. Right, and now things are moving to the cloud, and all of a sudden you have another dimension which you have to take care of, which will be the cost of storage and cost of moving data and cost of processing your data. So I will mention Glue, Apache Glue in passing as an example of a system which would alleviate you from many of the hassles of on-premise development, but I would also would like to heighten your awareness of some of the cost-benefit aspects of it. And generally, you will be dealing with big data. So as you know, big data is characterized by three attributes: velocity, volume, and variety, but mostly it's all about processing data which are commonly either too expensive or not very convenient to process using the traditional systems, which are relational databases, RDBMSs. Currently, what has been established is the three data-related roles in enterprise or in any web culture type of projects. So you have at the top of that totem post data scientist. It's very some people just tend to think about it, but in fact it's not. Actually, I would reverse this a list starting with data engineers, because that's the root of the whole thing. It can be the root of all the evils, and it can be the root of all the successes. But that's how, I guess, at least people at enterprise C-level would like to see things. So data scientist who actually uses data generated or acquired by organization to perform some sort of a machine learning modeling of data, to make predictions, maybe find some trends in the data. And it's a whole kind of a big topic in itself, but nothing would actually happen and nothing would come out of that big black box if data is not properly processed and data is not cleaned, not maybe normalized and repaired, which is the responsibility of the data engineer role. Data analyst is someone who is probably sandwiched between the two, and many people are just tending to embellish their resume and say that I'm not a data analyst. No, I used to be one last year, but now I'm a data scientist. Probably they have taken some Udemy courses, and that's how they want to position themselves. But data engineer is definitely a very distinct role, which supports both roles, be it data analyst or data scientist. This is the lay of the land. This is a typical data processing pipeline where you have the full cycle of data acquisition or data ingestion and all the way through to processing data and developing some sort of a machine learning model. So that's where people are striving. This is the sort of a blueprint or the vision that many organizations are trying to implement in their respective organizations. If you can see, there are three type of labels, which are legends. If you can see the colors, the blue one with the DE letters symbolizes data engineer, followed by data analyst and data scientist. So that's where I guess things are ordered properly, in my opinion. So as you see, data flow goes from the left to the right. So we ingest data, and data comes from possibly some sort of transactional log files. Maybe it would be some sort of a click stream, or maybe data that you get by way of partnering with some other organizations, business to business type of communication. And that data can be, before it gets moved any further, it needs to be cleaned. It's a big topic in itself. Cleaning data involves making sure that data complies with the data model that you would use down the road, or reports that you are going to generate, or maybe dimensional mappings that you will be using in your OLTP systems. So that data that has been cleaned represents a good base for building some sort of reporting presentations of your data for consumption at any level in your organization. And if you would like to apply more advanced processing of data so that you will have multi-dimensional cubes, OLAP cubes, then you can also, at this point in time, end any movement of the data. But with the modern approach with data science, machine learning, kind of getting traction within organizations, things are not done at this point in time. So what happens after data has been cleaned, you need to start getting the most out of data. And usually what's happening is that I guess data scientists take over. They will start performing such activities as feature selection. Feature would be a column attribute of your data. Data sampling, so that you don't have to move around terabytes of data, but rather you would, using some sort of a sampling techniques, start maybe performing some sort of a hypothesis testing, so that you would operate only on a significantly smaller sets, kind of a subsets, maybe 10 or 1% of the data, which would be representative of the population, so that you can get statistics, so that you can infer some of the properties of your data. And I'm not going to go into all the details, but as you see, all of those activities, the whole range of machine learning or data scientist activities, they are predicated, they are so much dependent on data engineering um, work and the success. And the earlier you fix your data, the better the results would be, and that time to insight would be significantly faster. Most likely, many of you have seen this diagram before. It's all about data science, but what's interesting is data science is just kind of a big Uber overall concept, kind of a moniker, which actually is just kind of a label for a number of activities. And data engineering is part of it, and I would say it's probably one of the most crucial part. It actually I guess, deals with other activities with domain expertise. So whenever you process data, you need to know how to treat your data, what would constitute an outlier, what would constitute noise in your data. So someone needs to understand the data. Otherwise, it would be garbage in, garbage out. Right, and the more you know about statistics, math, the better you would serve the ultimate goal of building those fancy machine learning models. So core skills and competencies for data engineer, it's quite indispensable not only to know programming languages, that's a given, that's what you would expect. And by the way, Python is the language which has really won the hearts of data engineers, even though it might not be as performant as, say, C#, Golang, Java, but it has its own, I guess, values. It can kind of expedite processing using NumPy and other systems. You can have a native bridge. The version of Python that we are using is written in C, so you can have native bridge and you can speed up things significantly. But in addition to that, you also need to have, as a data engineer, you need to have kind of people skills so that you can talk with those very obstinate and sometimes kind of nasty, toxic sysadmins and very kind of a highbrow data analysts, data scientists. So essentially, you have to have some nice communication skills so that you can, I guess, support those people and at the same time let them know that your work is indispensable, absolutely. And since your activities as a data engineer fall under the umbrella of ETL processes, that's kind of a big topic in itself. In many cases, it might be just extract and load without any transformation, so that the schema would be excuse me, applied at a later time. So that's the case with Hadoop, where you would have schema on demand and the way you want to treat the data. And when you perform those ETL activities, you need to be cognizant of a whole plethora of things related to scalability of computations, system interoperability. How would you make sure that the data that arrived as some sort of unstructured data, maybe encoded as JSON, would be more efficiently processed? So definitely JSON is not the best way to process data. How would you convert it into a Parque format or RC format? And while you, as a software engineer, data engineer, can push it out to kind of pass the buck and let other people solve the problem, it would be very beneficial to yourself. You'll do yourself a big favor if you will be, as I said, cognizant of all those aspects. Right, and of course you need to understand data normalization and where normalized, where not normalized data, so that you would do your job more efficiently, and you would have kind of a good karma overall in that big kind of area of data processing pipelines. So Python, why Python? As I said earlier, Python might not be the fastest language and maybe not the richest in features, right? Definitely it's not Scala. Definitely it's probably not C, but it does the job in a very efficient way. And what's interesting is that it supports not only the traditional imperative programming model, object-oriented, which is probably it wasn't created for, but it supports functional programming paradigm, meaning that you can express your intents for processing as functions and pass them around. So it supports map reduce, filter type of operations, and that's where it's quite natural to, as you know, functional programming lends itself to scaling because you just express your intent in some sort of a declarative way in terms of lambda functions, and then those lambdas, they can be scaled automatically. If you transition from one platform, like Python is a standalone application, it's a JVM, not JVM, it's a virtual machine which just performs a dual work of translating Python code and then executing in one go. It automatically garbage collects objects, unused garbage. It has a garbage collection, and it has some nice features. You can use threads to speed up processing, to parallelize, but the primary, I guess, the usual way of using Python is on a single thread of execution, so that you don't take advantage of multi-core architectures of your computers. So Python gives you what I personally like about Python, that it's just very unobtrusive. Definitely the lack of typing might be a little bit of kind of a gambling if you have a very large project, but usually if you can put your application in your head, you would definitely trace all the type conversions. The Python would help you a little bit with this regard at runtime, but generally it's not happening like with other systems, like with Eclipse or IntelliJ, where you would be catching lots of those problems in creating programs, say in Java. It will just point out that no, it's not possible. But list comprehensions, zipping of the lists, the wide range of libraries to work with HTTP endpoints and perform compression. And generally, it's very pleasant language to work with. It just goes naturally. If you become more or less proficient, probably it'll take you maybe a couple of months to just start understanding and appreciate the language. And the good thing is that once you have learned Python, you get into this habit, and it's kind of a proven, it's a machine-oriented way. Generally, you would be thinking in those idioms, kind of combinations of different patterns to create very quickly. You gain great developer velocity. And when you're stuck with that single machine, probably you will be experimenting with multiple threads. It's possible. Python supports multi-threaded processing through libraries, but you are better off to switch to clustered programming, where you would use the same, for the most part, 90%, maybe more, of the syntax of the language to process data on a cluster. Why is it possible? Because of the functional programming paradigm, because the map reduce, filter, and the other programming idioms or procedures would help you to transparently process data on a cluster, where your data set would be seamlessly and independent of you behind the scenes processed, spread across a cluster of machines in blocks, and the system would then allow you to process the data in parallel. And essentially that would be the solution. So you have a way to automatically scale your applications by just switching from one platform to another. I guess that's a big winning point for Python. And currently, as all of you probably know, the popular REPL is Jupyter Notebooks, Web UI, and that's where things are. And cloud vendors now offering similar capabilities around Jupyter Notebooks. Python in itself rather computationally inefficient. Everything is some sort of kind of an object, be it a number, be it a string, so that there's no primitives like in Java, where you would have an integer, Java integer object, or you would have a primitive which takes up 4 bytes and could be put on a stack. But you can achieve some efficiencies through extensions. For example, I mentioned NumPy, Pandas. There are other libraries from SciPy library, a set of libraries, which essentially are using the native bridge, which you can call out processing in C at native code, where things would be allocated, deallocated automatically, and then clustered processing. Or PySpark, it's a version of Python running on the Spark platform. So we're not going to introduce, for the most part, what Spark is. Essentially, it's just a way to speed up processing on Hadoop. So Hadoop was born out of the necessity to process large amount of data. So Yahoo was pushing this agenda quite extensively. Google did the original work, published paper like around 2004, and they did this, I would say, illustration that it's possible to use functional programming in terms of MapReduce to process data at scale. Not everything. You would probably need several MapReduce jobs to process data sequentially, but generally it's the right approach. And cloud vendors, they have taken this approach to the next level. They allow you now to take Python, or more specifically PySpark, and run it in the cloud. They create so-called managed environment where the cloud provides you provisions all of the necessary components of the system so that you will be able to go through the whole development cycle from data ingestion, data processing, and data storage by staying in the cloud. And they also give you very productive REPL environments. Mostly those are Jupyter notebook based systems. For example, an excellent example is AWS Glue. So Glue, it's a very nice way to name the system. I guess Amazon, to their credit, they have that, I guess, ability to come up with nice names like EC2, S3, and Glue is just a nice way. And that's exactly what it is. They just borrowed Spark platform, and they build on top of it kind of a thin layer. They provided very tight integration with S3, other services, and they give you Zeppelin notebooks or SageMaker notebooks where you can develop your programs as if it were just your regular standalone Python application. And that's where I guess things are moving overall. So let's take a kind of a closer look at how you would be dealing with some of the more important, and usually those are mundane, run-of-the-mill type of exercises, but they are absolutely critical to make sure that the people down the road, down the stream, use your data in a more intelligent way. So you will have, you'll be challenged with a number of input data irregularities. So it can be missing values, and usually it happens that data points have been skipped or missed, not captured at source, and usually it happens with large volumes of data. So if you have that kind of Internet of Things type of system where you collect the information from sensors, be it temperature sensor or geospatial locations, and some data might be missing. Usually in such cases, it would not be TCP/IP, it would be UDP type of processing. The broadcast is not reliable mechanism, so some packets might be missing. So for that, you might be missing some data, and data might be in inconsistent formats. And usually that happens if you have a situation where you have onboarded maybe another partner, and all of a sudden they just missed a particular point. Maybe you have made an upgrade. How would you deal with those inconsistencies, right? And usually you don't have much time to correct the things. And for that, Python would definitely be a good language where you would perform a better data modeling, so that you can map data representation in one format and to get the output into the format understood by the target system, right? And the application of the data, it also happens, usually it happens with queuing systems. If you don't have quality of services like a one only message type of constraint quality of service, then you would have duplicate records, duplicate messages. And usually you have to find a balance of like S3 on Amazon, they might give you that headache. And it will be up to you. The onus would be on you to prove that this duplicate and this duplicate should be discarded. Right. Of course, if it's a mission critical applications, banking, some sort of online banking or transactional system of some sort, definitely it's absolutely a critical bug if data gets duplicated. Right. You do $1 million transfer from your account, it will be duplicated for whatever reason, and that's it. You go out of business, and then all you have to do with the recourse is Supreme Court. Right. So lots of those things, they might kind of look kind of some sort of a small application bug, kind of a defect or glitch, as higher up people would like to name it, but they can bring about just all out business disaster. Right. So not paying attention to those small details is just a recipe for problems down the road, and big ones. Right. So some sort of a kind of a small it's kind of a devil where it will always be in those trying to hide in those small details. Outliers, it's called outliers. It should be outliers, and not normalized data. So outliers are those which you need to kind of treat as those, sort of mavericks, some sort of square pegs in round holes, but you should have some sort of way to define one as being such. You should have the whole probably machine learning model to recognize the data as being an outlier. And it would be kind of a catch-22, basically. So that might be a result of a number of things. Generally, outliers very rarely give you some good value, but if it is, it might be gold. So discarding outliers, it's kind of a throwing a baby with the bath water. So you as a judge. Not normalizing input data. In most situations, it would be the responsibility of data scientists, machine learners, who would be scaling data and not normalizing, just making sure that it doesn't create some sort of skewness in your data. It would be treated more. Some algorithms in machine learning, they're quite insensitive. They can tolerate data not being normalized. Others, they're critical, very dependent on data being properly scaled. It can be, I don't know, some sort of a z-score, or you may want to to scale data to being in the range between 0 and 1, -1 and 1. Easy to do, not a big deal at all. Just be aware that you might be tasked with those requirements. Dealing with the missing data, it's again one of those tasks that you need to take care in your job. And the options for dealing with missing data are quite a few. You might decide to remove the whole row, which is treated as an observation in statistics or columns, like features attributes from the input data. It's quite drastic, and sometimes it's not a desirable approach. You are better off to find a better strategy, and usually it is about plugging those holes with more meaningful data, and like mean median values would be a good approximation. Also, interpolation helps as well. Particularly, this is important for temporal or time-stamped observations, where you can provide the missing timestamp by just observing the previous and the following timestamps, so that it will be congruent, it would be consistent, and it would be an intelligent way to do things. So in standalone Python, you have two major options for dealing with the missing data. Those methods are fill not available or interpolate. This is those methods. These functions are methods on pandas data frame. So df, it's a data frame in pandas, and pandas was developed specifically for the purposes of dealing with those nuisances. So what we're doing here, I'll do some highlighting for you. So this is a data frame. I'm changing the color. Which one would be good? I think green. So that's a data frame. Essentially, that's a column name, the attribute, a feature. And fill not available would be to find the mean for all the column values which are not empty, don't contain any black holes, and you perform in place, meaning that the updates would be done to the same data frame. This is pandas data frame. Interpolate, just a way to connect the dots. So if you have, for example, some values plotted along the axis, and you will have certain points like this, and then there would be kind of a missing point here. So interpolate would be just, in our case, to find any of the strategies to use all the preceding or following values to derive the value for that missing data. So nearest means it will essentially find the value of the nearest previous values, and it will just plug in that value. As you see, someone had a field day coming out with spline polynomial. Nice. So I guess you've got, you can plug in 0. That's kind of a, I have no idea what this is all about. Linear is a very popular one as well. So essentially you have some sort of kind of a dots, right? And then one dot is missing, right? I just put it here. So linear would be essentially saying, okay, I'm building that linear relation, and that would be my way to say that's how things would be calculated. I might be mistaken in some interpretation, but generally that's how things are. I guess you should look at the data before you start using any default values. Otherwise, it's very, very important exercise. With PySpark, so far we've talked about standalone Python. And does the job, does it very nicely. It's very efficient. There are libraries for that. Those methods are extremely powerful. With PySpark, the same processing is now like fixing, repairing data, providing plugs for data holes will be done on the cluster. Just imagine you have several terabytes worth of data, and the data has been accumulated over a period of time, and you have lots of kind of a missing data points. And then instead of using Python, which would probably take you, I don't know, a week to perform all the processing, you would just switch to PySpark. And this is a regular Python, except for different libraries that PySpark or Python on Spark platform will give you. So you are on a cluster already. So this code will run on the cluster of machine. You would bootstrap it from the command line or otherwise, and then system would schedule processing on the cluster. And you would need to import that imputer class. You need to specify the columns where you would like to fit. The default is the mean strategy, and output columns is just a way to it doesn't perform that in place processing. It would create additional columns which will contain values with the corrected results, and it just follows that mm, kind of idioms for fit and transform, borrowed from scikit-learn, standalone machine learning library for Python. And you feed your data. It's the data frame, similar to pandas data frame or R data frame, which contains nulls. And then that imputer would essentially learn, traverse all the data, and it would create a model. So it will be a 2-day exercise, a 2-step process interface. So you feed. It's just that's how they do it. Not quite I would say elegant, but they just wanted to create a uniform API which is built around instantiating, fitting data model, and then transform. So essentially they treat that data fixer as a model. And then that model will perform transform, which would essentially take the strategy of mean and those columns, and it will go through all the data, which might be millions of records, maybe hundreds of millions of records, and it would apply the strategy. So that df mean new data frame would contain the output columns, which would have fixed values. Nice. It can run hundreds, maybe thousands times faster, because what PySpark brag kind of has the bragging rights that it can perform lots of processing in memory. Of course, you can get easily out of memory exception or other like similar nasty outcomes. But PySpark, generally, it's a robust system. It would try to fix by replaying all the activities on another machine. But if it doesn't help and you don't have enough RAM, machine memory, you'll get out of memory exception. And you'll need to configure the heap size, the executors space, and lots of things, drivers space. But generally, it would work if everything has been properly sort of provisioned in terms of the heap size. PySpark runs essentially Spark is JVM, and there would also be the Python runtime sitting next to it, taking some space. But all the processing will be done delegated through that Python Java bridge to Java. And you will need to learn a little bit of Java to make sure that you don't have those nasty out-of-memory exceptions. So I'm going to one of the topics that might not be immediately registered with you, but it's a big win to understand what you can gain by using columnar stores. By the way, both standalone Python and PySpark, they support columnar store processing. There is an API for that. And the most popular one is Parque. So if you have, for example, half a terabyte of original data encoded as text, it might be CSV, it might be JSON, XML, or I don't know, just flat file. If you use Parque, which is the most popular format popularized by Cloudera, and now that Cloudera has joined forces with Hortonworks ORC, I guess I don't see it as more present. I guess Parque has won by a combination of the compression ratio, and so essentially you can see that Parque format gives you 62% compression compared to the original data. RC file is no longer relevant, I guess. Discarded. ORC gives you better compression, but at the expense of time it takes to compress the data. And it looks like the consensus is to use Parque. Of course, you would need to perform additional compression. It's just a way to perform columnar storage. And down the road, it's not only about saving storage space, but also if you have your data partitioned using some attributes, some properties or columns in your data, then the queries that you would run, be it Hive, Apache Hive, or be it Spark, PySpark programs would be significantly faster, because it's a way to build a clustered index. If you are familiar with that concept in RDBMSs, so clustered index organizes data in that index as it was just native storage. So data would be stored in ascending or descending order, and whenever you perform a search, it would be much faster to perform it on assorted data. So it'll just use, I don't know, regular binary search, finding significantly faster if the data were unsorted. Okay, so Parque is a great way to speed up things. And to just illustrate, by the way, we are in no way associated with AWS. We are not endorsing them, or we otherwise kind of supporting them, but they just have showcased in a very nice way some of the benefits of using columnar stores, and that's why you can see this slide here. So it's all about speeding up things using, I believe it was Hive, and that's a select statement that they're using. That's a source, and they were able to save significantly by just going through the traditional 1 terabyte worth of data, where the query would take about 4 minutes to process, and the cost would be $5. Of course, it's not a big deal, right? You can just save some money on your coffee and run this experiment. But if you look at what you can achieve, and there's always a gap between what is possible and what you currently have, and you go with the Parque format, I am referring to this one, which is supported in both Python and PySpark, you would be able to achieve almost 90% storage savings, and it will run like 34 times faster, down to 5 seconds. It becomes near real time. And what's interesting is when you start going with columnar store, the data scanned in order to produce the result of that projection, a SQL projection, you will be observing that the data scanned, data storage would be significantly less data scanned. You see, it's almost 99% less data scanned, which would result in faster times, and it would also bring down the cost of your cloud bill, because they charge you per hour. In some cases, they might offer you a per second or per minute charge, but generally you save down the road. That's what business people would love. If you just approach this traditional problem by looking as a data engineer, where you would understand the benefits of columnar data format and using the cloud, instead of building the whole cluster and probably investing millions in hardware, infrastructure, security, all that stuff, hiring people, that project might go for years. And things would change dramatically maybe in 6 months. But if you go with a cloud solution, by the way, Athena is just one of the systems which allows you to process data that's stored in S3 statically. And you get, I don't know, you would be paying pennies. Of course, Amazon will compensate their work in other ways, because they have hired the smartest marketing people. You'll be probably paying somewhere else, but generally it might be a cost-efficient way worth considering. So that's yeah. And now the question would be, okay, I've got data in text format and I process the data. Probably it's JSON, or I don't know, maybe just CSV. And what is involved in this? And let's look at this, how easy it is. By the way, there is a library in Python, which allows you to do the same thing. You take a data frame and you just write it. It's a nice way to say, I would like to use the Parque method of that writer class. It can be JSON, it can be CSV. They have Avro as well. And you specify the directory where you would like your files to be stored. And you specify the compression, because compression needs to be laid on top of data store. That's where you would achieve significant compression ratios. Okay, so and that, by the way, there will be a number of files which would start with part, and they would end with gz Parque. That's the way to indicate that those files, there would be multiple blocks. It may be one or maybe hundreds of those blocks. And together they would represent the compression, compressed directory Parque file. So that's it from me. And yeah, that's the class that we are offering in this regard. It's a bootcamp, very intensive training. You can just come to this class. It would teach you Python. It's no nonsense. You need to have some background in languages. It's not just going to go, programming is all about putting it on the computer. It will be high octane, high paced training. You'll be trained also in standalone processing of the data using Python as well as PySpark. And you will see all the ways, the common techniques used in repairing data, scaling data, handling data in different formats. Thank you for attending. I hope that you found something useful in my presentation, and just keep experimenting. If you haven't used PySpark, but you know Python, the best way for you would be to go to Databricks community cloud. That's where you can get runtime quite scaled down, but it's good for experimentation, for prototyping.